Hi, Professor Cavallo. Good morning.
Good morning, Sarah. Morning, everyone.
Hello. Hello, Professor Cavallo. Thank you
Hello,
for
good
joining us.
morning.
I
Oh,
really
my
appreciate
pleasure.
you. I really appreciate
Oh,
you that kindly accept our invitation for this webinar. I don't know how can I be thankful to you. It's great. It's wonderful.
oh, no worries.
Thank you for presence
You,
and taking
you,
time out on your busy schedule. I know we are very busy, and you kindly give the time to us to have this
uh,
presentation.
my pleasure.
Thank you.
You already gave me a very good, let's say, gratitude by sending Sarah to us.
Thank you. Thank you.
Thanks so much.
Thank you, Professor. If you let me, Professor, I will have a very, very short speech for our audience, and then I will ask you to kindly start your presentation, okay?
Thank
Hello
you.
and welcome to, thank you, Professor. Hello and welcome to today's presentations with the title of Effective Bonding to Ceramic, a hot topic for the restorative dentist. I'm sure very useful and practical information we deliver today in a clear manner, and I fully expect that this webinar will influence your practice in looting of ceramic restoration. I'm Fariba Mutavassilian, the Vice President of International Affairs of Restorative Dentistry Department of Tehran University of Medical Science Faculty. I'm thankful to Dr. Valizadeh Sarah, the Associate Professor of Restorative Dentistry Department, for making this webinar possible by connecting us to Professor Carvalho from University of British Columbia. Sarah?
Hello, everyone. Thank you to all audiences for taking time out and being here today with us. I would like to thank Office of International Affairs of Tehran University of Medical Sciences for kindly support us, and I'd like to appreciate Dr. Mir Hashemi, the Head of International Affairs of Dental Faculty of TUMS, for organizing this webinar as well. I'm very happy to have this great opportunity to be at UBC in Professor Carvalho's lab as a visiting professor. And I would like to extend my highest level of gratitude and thanks to Professor Carvalho for accepting our invitation and joining us in this webinar. Rika, I know that you have a very busy schedule. Thank you for the time devoted for TOMS.
That's right, that's true. Thank you, Sarah. I would like to introduce today's presenter, as you found, Professor Carvalho. I would like to welcome him again. Before listening to the speech, our guest lecturer, I would like to present a short biography of Professor Carvalho. Professor Ricardo Carvalho is a professor and head in the Department of Oral Biological and Medical Sciences at the University of British Columbia. He is a world-famous lecturer. He was a lecturer at many universities: University of Sao Paulo, University of Florida, University of Hokkaido in Japan, and he is the director of research and development of Bisco Company. He's the editorial board of several well-known journals. He has published hundreds of scientific articles in the very famous journals, and his interests and research interests include of uncovering the mechanism and materials involved in degradation of adhesive joints to mineralized tissue and finding ways to prevent it. Now we have the chance to have one of his presentations today in this webinar in Tehran and around the world again. This lecture takes about 1.5 hours, and we will running the live question and answer at the end of this speech, about 10 to 15 minutes. You can write the audience question in the chat box as well. If you're missing anything, don't worry at all. We're sending you the link address of the recorded webinar if Professor Carvalho let us do that. At the end of this speech, which would be available on the next week probably. And Professor Carvalho, the stage is yours, please.
Thank you. Thank you so much. Thank you all at TUMS for the invitation. Sarah is our link. It's been a pleasure to have Sarah here with us. I really appreciate this potential enhancement of collaboration that we should have in the future between UBC and TUMS. It's just a fantastic time. And, you know, technology is what we see today. I am here in Vancouver. Sarah is here as well. And all of you folks in Tehran or Iran, spread it all over the country. it's just fantastic that we can speak and we can communicate, and hopefully we can learn something today in terms of bonding to ceramic. So again, I appreciate the invitation. I appreciate the kindness for arranging the time, all of you folks. This is a pretty much almost weekend ahead, and I appreciate that you folks spending the time to listen to me today. I will then start sharing my screen here.
Yes, please.
Yes, here we go. I hope everybody can see the screen.
Yes.
Yeah.
We can.
Very good.
Thank you.
Let me put it in the play here. Okay. Let me hide this little thing here in the corner. There we go. Okay, once again, my goal here today is to give you a brief, comprehensive understanding of how we bond to ceramics. And I usually try to put this into, of course, the dental materials aspect of bonding, but also I always try to correlate that with what we do clinically, so then people can really understand the rationale behind the things. As a UBC regulation, I am expected to disclose that I don't have any conflict of interest in making this presentation, and also that you will see some images, materials, etc. That doesn't mean that I am indicating or suggesting or endorsing them. They just are part of the presentation here. In other words, I'm not being paid by any company or anything else other than UBC. So today, again, we will discuss the steps that we have to proceed in order to be able to bond to feldspathic, lithium disilicate, and zirconia type of ceramics. Well, people all around the world, they used to call ceramics in different ways. I usually use this publication from some friends of mine in New York University, in which they kind of organize the distribution and classification of the ceramics that are currently available, and hopefully some that will come available. And today we will talk about these groups. On the glass matrix ceramics, the feldspathic group, and still on the glass matrix ceramics, we'll talk about lithium disilicate. And then on the polycrystalline ceramics, we'll talk about the stabilized zirconia, which are, of course, let's say, the most popular materials in terms of ceramic that are in the market nowadays. Well, the first question I usually ask clinicians is why you were bonding? Why you were bonding to ceramics, right? And people would say, well, I want to have additional retention, which is for sure, if you can add a bonding mechanism to your crowns or veneers, particularly veneers, you do need retention. You will also bonding because where you have margins, let's say with enamel in there, particularly, you're going to get certainly a much better marginal sealing. But I think the most important of all when we are bonding to ceramics is exactly to attain a functional support. As we know, let's say, except for zirconia, in a way, all the other ceramics are materials that require some functional support to withstand the clinical service. And like everything else in dentistry or anywhere in terms of bonding, the bonding treatment depends, of course, on the type of ceramic that we are treating. We have a general rule that says that silica-containing ceramics, they can be etched and therefore they can be silinized, simply because they contain silica in their composition. On the other hand, ceramics that do not contain silica, they will require different approaches, and that's what we are going to discuss today. So in this group of silica containing, we have both the glass matrix veneers, for example, and lithium disilicate also fall into this category. And in the category that does not contain silica, we have, for example, zirconium. And these are the steps, and we will discuss, let's say, each one of them when we are attempting, in this particular case, to bond to glass matrix ceramics. In a clinical standpoint, that's basically what we do when we are bonding veneers, made, of course, of feldspathic or glass matrix ceramic. And we will give special attention to hydrofluoric acid etching and the salinization processes, which are, to my understanding, the most important and the critical steps in bonding to ceramics and achieving a clinical success. Well, sandblasting. What is sandblasting, or blasting, just in a single word? Well, you probably remember when we used to make, and we still make today, veneers, for example, that are baked in the oven onto these special investments. That type of procedure, let's say, to produce ceramics usually come with residues from the investment when we remove the crown or the veneer from the investment. And that's why blasting was originally indicated, to remove those debris and expose the actual surface of the ceramic for further treatments. Usually, what is recommended for laboratories in general is just a brief sandblast, usually less than 10 seconds. And we also are expected to use low pressure because ceramics, particularly the glassy matrix, are very brittle, as we all know. And it's quite easy to break them if we don't care, if we use a lot of pressure or different size of particles. So the recommendation is, when you have to sandblast, to use this kind of procedure. But as we know nowadays, with all these CAD/CAM milled veneers, or even 3D printed as it's coming, usually the sandblasting step is not necessary because the ceramic surface already comes clean from these milling machines. There are no residues. Hydrofluoric acid etching, however, is a little bit more important, if you will, for the bonding. What hydrofluoric acid etching does, it removes the silica from the surface and increase the surface porosity, which will then help in promoting micromechanical retention to these veneers. It also promotes a chemical change on the surface that it raises the surface energy. And we all know that by increasing the surface energy, you facilitate the spreading of any other components that you're going to place in there. In our case, the silane. And the recommendation, as we know, we have different types of ceramics. So feldspathic or glass ceramics, even though they are based on feldspathic composition, but of course, from manufacturer to manufacturer, they vary. And the recommendation that is apparently good for all of these in terms of increasing porosity and increasing surface energy is to utilize a 9 to 10% hydrofluoric acid etch concentration, and the application time is 60 seconds. That's when, let's say, the most critical aspect of bonding to ceramics start. After we etch the surface with hydrofluoric acid, the surface becomes highly prone to contamination because we are raising the surface energy. Everything that touches the surface from that point on will readily spread on the surface. There is an issue because, as I mentioned, some ceramics are different than the others. So the average 60-second etching time is an average that is applied to all ceramics. But there are certain cases in which we over-etch the surface. And that is really important to realize and be able to recognize over-etching phenomena clinically, because overetching will actually deposit some residues, a residue of salt formation on the surface that might compromise your bond. So it's really important that you, after etching, you rinse well with water and you dry well with air. And then you look at the surface of your veneer, for example, and if you see these whitish areas, sometimes all over the surface, that is the clinical indication that those particular areas were probably overetched. And what you see here actually is a layer of residues of salt formation because of the hydrofluoric acid reacted with the ceramic surface and formed some salts. These are particles that are loosely bound to the ceramic surface, and therefore they must be removed before we actually apply the silane or the bonding, because otherwise we will compromise the adhesion to the ceramic. And how do we remove this residue if I notice them clinically? Well, I can either ultrasonicate in ethanol for 5 minutes. If you have those ultrasonicator bath in your practice or nearby, you can just do that for 5 minutes. Or better yet, since you are chairside, you are seeing your patients, the easiest way to remove those debris is by just simply etching the surface now with phosphoric acid, the same acid we use for bonding to the enamel or dentin. We just quickly apply on the surface for 10 seconds. We rinse and dry well. Phosphoric acid will then dissolve these salts, remove the debris, the residue, allowing then the surface ready for silanization. Silanization is highly important aspect here because that's when we're going to accomplish the chemical bonding to the ceramic surface. So we already have the porosity to increase our micromechanical retention, but we also want to stabilize that bond by a chemical adhesion to the ceramic surface. And as we know, silane is exactly this coupling agent who will allow for the chemical bonding between the ceramic particles with the resin matrix. And silanization for the clinical perspective is really a simple procedure, and we should pay attention because although it is simple, it can be quite damaging to the bond if we apply it incorrectly. So ideally, silane should be applied in a very thin coat, 1 or 2 coats of silane. And after you apply the silane, we recommend to dry with warm air for 30 to 60 seconds. And you will see this. Why we do this, of course, it is not something that you must do, but you will see that doing this, you are going to improve the bond strength to your ceramic. What is really important after applying the silane is that the surface should not appear shiny. If I have a veneer on my hand and I silanize it and I show it to you, you should not see anything. The comparison between non-silanized and silanized surface should not be different. And that's a kind of critical point because everybody is used to apply adhesive to enamel and dentin. And after you apply your adhesive, your surface should appear shiny. You should be able to see that the adhesive is applied over there. But the silane is the opposite. Silane, you will see that if there is a shiny surface, that is a clinical indication that you probably applied way too much silane. And as we're going to see, excess silane is a big problem for bonding. So if you do see a shiny surface after you apply your silane, that's probably an indication that you applied too much and you should start over from sandblasting. And then for hydrofluoric acid and silanation again. This is just a diagram explaining how the silanization happens. It's a chemical reaction, creates a covalent bond between silica on the porcelain surface and the silane in this surface. And then, of course, this radical is the radical that will bond to the resin matrix. What is really important is that for every molecule of salinization, there is a production of one molecule of water. So the salinization process itself produces water on the surface. And that water, along with the solvent that is present in the silane solution, they must evaporate from the surface in order to allow a proper chemical reaction of salinization. And that's why the time allowed after salinization is really important, and we're going to discuss that as well. But let's say we have the ceramic surface here, and then I come and I applied my single layer of silane. That's what I want to happen. Clinically, if I had microscopic eyes, I would like to be able to look at the ceramic surface and see a single layer of silane deposit on the surface. The reason is the bond between this very first layer of silane and the ceramic is really strong. But if I apply way too much silane, we're going to start building layers of silane on the top of other silane. And that is the most important issue here, because excess silane will cause the bond between two different layers of silane are rather weak, and they may hydrolyze with time. The bond between the first layer and the ceramic is very stable and tend to last forever if there is no physical removal. But if you apply excess silane, the layer after layer of silane on the top of each other may eventually hydrolyze and degrade over time. So this might be a clinical failure down the road when your veneer simply debonds or detach from the surface. And then when you look at your veneer, you'll see that most, if not all, the resin cement remained attached to the tooth surface, and the veneer just pull out like clean. That is exactly a salinization problem that you might have overcome. Overetching is also not recommended, as we discussed it, not only because it forms those deposits on the surface, but also if we overetch, we create larger porosities, we damage more the surface, and all the solvents and the water produced during salinization will be harder to evaporate. And evaporation of those solvents, it's really important, because only after they evaporate, that's when the chemical reaction of salinization actually occurs. And that's why I always tell my my clinicians, always keep them together. So as you could see here, hydrofluoric acid etching and salinization are two procedures that should one follow the other right away. And the reason is because I should avoid contamination of the surface after etching with hydrofluoric acid and before the salinization. And this has, as you might expect, a lot of implications in terms of your practice, because you certainly work with a dental laboratory, right? And who does the hydrofluoric acid etching plus the salinization? Do you leave it up to the laboratory to do everything for you? Do you receive your veneers etched but not salinized? Or do you receive your veneers only blasted and you do your etching and salinization chairside with your patient? Well, you have to discuss this with your lab, because as we see here, salinization, which includes the hydrofluoric acid etching, is a very critical step in ensuring or securing that you have a really good bond to the ceramic. So if you trust your lab, if you know what they're doing, that's a good sign. But if you don't know what they're doing, you just receive the prosthesis or the pieces without understanding what has been done before, it can be quite risky for your final service. And the reason I say this is this is a very, it's a small paper. It was published in this Dental Edges, which is just a regional publication. But Dr. Gary Alex is a friend of mine. He's a faculty in Stony Brook University, New York. And he did, I mean, this is not a scientific research, but he did just for the sake of curiosity. He was going around dental laboratories and asking the technicians, how do they treat the surface of their porcelain or veneers in their particular lab. And he did that, he discussed that with about 11 different dental laboratories. And the result was like amazing because, first of all, he didn't see any specific protocol of any laboratory. He learned that all laboratories, they always treat the intaglio surface of the veneers with hydrofluoric acid. Okay, that's fine. However, only 2 labs actually knew the concentration of the acid they were using. Among the different laboratories, the application times varied from as short as 30 seconds to as long as 10 minutes. So you can imagine how different the surface looks like in these different scenarios. Probably a lot of residues, a lot of over etching in the cases of longer etching time. And several laboratory technicians stated that they simply etched the veneers until the surface looked frosty, right? So which is exactly what you don't want to do. Oh, the overall idea here about these curious work by Dr. Gary Alex is exactly this, calling out the importance of understanding what your laboratory is doing. Because in theory, I'm teaching today and people know what to do with the veneers, but if you leave it up for the laboratory, you have to assume they know what they're doing as well. And that's not necessarily true. So the safer protocol for you is, if you have a chance, ask the laboratory just to send the veneers to you. Do not etch in the lab, because if you etch in the lab until it reaches your hands in your practice, there is a huge time frame in which the surface can be contaminated. And when you are handling your veneers in your practice, if they're etched, you have to be careful, not contaminated with any oily surfaces, with any powder from the globes, or anything else, including the dry ink paste is a contaminant and should always only be used after you silanize. So if it comes etched from the lab, be careful. Ideally, you should do it by yourself on chair side before you are bonding any of your ceramics. But how do you know? Let's say if the lab tells you, well, I send you already etched and silanized. And as I told you, if you just look at the ceramic surface, you cannot tell if it is silanized or not. So how do you know? There is a way to learn that. After etching, the surface usually becomes highly hydrophilic. It's probably hard for everybody to see here, but this is a block of ceramic that I etched with hydrofluoric acid etching. And then I dropped a drop of water here on the surface. As you can see, the water spreads readily on the whole surface. And then I rinsed, I applied the silane, and after the silanization, the surface must become hydrophobic. So that's the difference. You can only see the chemistry that is changing on the surface. And after silanization, when I apply a drop of water, the water does not spread, indicating a hydrophobicity on the surface and an indication that silanization actually occurs. And we can actually measure this contact angle between this drop on the surface, and we can somehow quantify how well the surface is silanized by utilizing the contact angle. And that's the important stage. Avoid contamination from here to there, because after etching, imagine if I place my trying paste here right now, it will spread readily, it will get into the porosity, and all those trying pastes they contain granular color dyes, and those can be entrapped in the surface, and it's hard to remove. So after you etch, you silanize first, and then you do your trying, you do your anything you want to do, because then it's easy to rinse because it is more hydrophobic now. The ideal protocol then, or sequence, would be sandblast if necessary, and then hydrofluoric acid etching, silanization, ideally done chairside, and then you can do your trying, you clean, and then you are ready for cementation. You have to understand that silanization, the silanization itself, the chemical reaction that occurs on the surface of the ceramic, it's a very strong bond. You do not remove, you do not damage silanization by rinsing the surface with water. Even rinsing the surface with phosphoric acid after salinization does not destroy silanization. The only thing that will compromise silanization is either excess silane, or if you have to make any adjustment into the crown surface, if you're dealing with a crown or if you're dealing with a veneer, whichever, after salinization, if you have to make any internal adjustments, then you have to proceed the etching and the silanization again. Other than that, no chemical solution usually used in the clinical practice will damage salinization. That's why after salinization, that's when your surface for bonding is protected. Another very important clinical question is, well, when I apply my silane, how long should I wait before I can apply my adhesive? Well, that's quite an interesting question because, for instance, if you guys use a 3M primer, ceramic primer from 3M, and then you read the instructions, you won't find how long you should apply the silane for. There is a general consensus that people apply silane for 60 seconds, 1 minute, or leave the silane on the surface for 30 seconds, or some people leave it overnight. It's quite confusing. And then, of course, on the clinical aspect, you want something that happens fast. But we cannot forget that silanization is actually a chemical reaction that takes some time to fulfill its goal. And as I mentioned before, by utilizing contact angle, I can actually trace how well the chemical reaction on the surface is happening. The higher the contact angle indicates the more hydrophobic is the surface, and therefore more effective was silanization. So we did this study when I used to work for the company Visco, and we measured the contact angle after we applied the silane. If we didn't apply, like this flat surface ceramic, the contact angle with water was 20, and then I applied silane and waited for 30 seconds and measured the angle. As you see, there was no change at all, because 30 seconds is likely a very too short time for the silanization reaction to occur. And then as you leave longer, as you can see here, the contact angle starts increasing the longer I leave the silane on the surface, which is just a normal thing to happen. It's a chemical reaction, takes time. The more time you allow, the better the chemical reaction. But then, of course, after 5 minutes, for instance, to 16 hours, there was no difference, which is an indication that, okay, after 5 minutes, maybe my surface is completely or saturated in terms of silanization, right? So that's really important to understand, because sometimes people get the ceramic primer, just quickly apply on the surface, get the adhesive, apply directly without allowing proper time for salinization to occur. And silanization, as I mentioned, it occurs over time because we need to evaporate not only the solvent that is containing in the silane solution, but also that water that is formed on the surface during the salinization reaction. And now you can understand or appreciate why we recommend the use of warm air. Because if I use warm air for 30 seconds, my contact angle raises up to 87, pretty much the same level of a complete salinization. So again, there is no magic here. We are simply utilizing and seeing the effects of warm air, which facilitates, of course, the evaporation of the solvent, which is usually ethanol, and also the water from the surface. So the utilization of a hair dryer is not magic. It is just expediting the process of solvent evaporation and therefore salinization. And what I usually recommend clinicians is, well, if you don't have a hair dryer or any warm dryer, just go treat your porcelain first, apply your silane, and just leave it on the surface. And then you go for the tooth surface, isolation, whatever you have to do, etching, bonding to dentin, enamel, whatever you, and within that time, your salinization is progressing. And by the time you are ready to apply your adhesive, you are with a salinization probably well progressed. Another question that I also hear from clinicians most of the time is, okay, I got this single bottle system for silanes and I got these two bottle systems. Well, the difference here is very simple. Single bottle are easy to use, but they are already activated in the bottle. You probably know that silane, the way it is sold by chemical companies, it is not really effective. You need some acidity in the solution in order to activate the silane and make it silanizable. And that's what happens here. In this single bottle, they have silane, they have the solvent, and they have a little bit of acid to activate the solution. And once it is activated, you have a limited shelf life. Usually, a single bottle silane will last maybe up to 2 years, but they are highly sensitive to heat. So if you have a warm weather, if you don't have a proper fridge, etc., to store, a silane solution in the heat of, let's say, 25 to 30 degrees for a longer period, it may just compromise the whole solution. And this is something that does not happen with the two bottle system, because what is a two bottle system? Well, one side is the silane and the other side is the acid. Once you mix, you activate the reaction, and then you have to allow some time for the reaction to occur, and you can utilize for salinization. The advantage here is the stability. Since the acid is not mixed with the silane before, you have a prolonged shelf life. How do I know clinically if my silane is okay to use? Well, silane should always be a clean, clear, transparent solution. If I'm using my silane and when I flip the bottle to get the drop and the drop is like milky, is getting opaque, unfortunately throw it away because that is already under condensation reaction and no longer provides a good salinization. Okay. And okay, what do I do now after the salinization is complete? Well, I have to, or I should apply a bonding agent to my ceramic surface. And the reason I should apply that is simply because, well, I have a surface that is full of small porosities. I have a surface in which I salinized the surface into those small porosities. Then I need a very fluid, low viscosity bonding agent in order to be able to penetrate into those porosities and accomplish the micromechanical and the chemical adhesion that I'm looking for. If I do not apply, if I go straight with my cement, well, the cement, I will get some bonding, but the cement itself is more viscous, and it will be hard for the cement itself and the particles to penetrate into those small porosities and accomplish better bonding. Some people recommend the bonding agent, ideally a hydrophobic, HEMA-free bonding agent, because as we know, some of these more, let's say, modern adhesive agents, they are highly hydrophilic. They contain a lot of solvents, and they are very permeable to water. And these might cause color change over time. And then, of course, it's not an issue for posterior tooth, but it might be an issue for veneers. And then you're going to use cement to cement your veneers. Hopefully, you're going to use a light cure only resin cement for the same reason that I don't want to have amines that might change color over time. So ideally, you should use a light cure only resin cement. I know a lot of people who use flowable resin for cementing veneers, which is also fine. It's similar to a light cure resin cement. And some companies understand that a lot of clinicians, they have dual cure resin cement in their practice. But dual cure, the traditional dual cure resin cement, they always contain amine for the self-curing. And they usually tend to change color over time, and maybe your veneers might get more yellowish. It might be an issue, it might not be an issue, but companies are concerned about that, and they now produce dual cure resin cement, but which are amine-free, which you then can use for veneers as well, if you are concerned about your cement changing color and compromising your veneer. Okay, this is how we do with feldspatic ceramic, but what do I do with lithium disilicate? Well, lithium disilicate, as we learned, is also a glass-based ceramic. So what do we do with these people? We do the same thing. We etch with hydrofluoric acid etching, with this only difference here. The acid concentration is different, it's a lower concentration, and we etch only for 20 seconds. The salinization process afterwards remains the same. I apply silane, I wait for the solvent to evaporate, a thin layer of silane, and all these other aspects. The only difference is in the etching step. And the reason why we use a lower concentration and less time is simply because lithium disilicate, although they contain silica, but they contain much less relatively to the composition. Therefore, we don't need a stronger acid, and we don't need a lot of time to create the porosities or increase the surface energy with lithium disilicate. So with glassy ceramics, it's that easy. We have to understand the steps. But what about zirconia now? Zirconia is actually zirconium oxide, as we all know, but also known as zirconia. What is it, and how do I bond to it? Well, as we all know, zirconia is actually placed in the metals or transitional metals in the periodic table of elements, and we never really see zirconia or zirconium as it is. We always find zirconium oxide in nature, and zirconium oxide, as we know, can undergo, it's a crystalline structure, can undergo a phase transformation. At room temperature, usually zirconium oxide, the way it will be obtained from Earth, is in a monoclinic crystalline structure at room or atmospheric temperature. And then what they do, they increase. If I raise the temperature of zirconia to 1200 degrees, I achieve a tetragonal configuration, which is, as we know, the strongest. And that's where I want my zirconia to be in order to produce dental materials with it. If I keep raising temperature, it goes to the cubic, and at 27 degrees, I fuse zircon. But if the temperature raises, this is what I see. If the temperature drops, the reverse is true as well. If I bring down zirconium oxide to the room temperature, it will always be in monoclinic, which is a very weak stage. I want here. And that's what the manufacturers did in order to be able to reach the tetragonal structure and then cool down to the temperature of the ambient or atmosphere and still remain in the tetragonal configuration, which is the strongest. Yttrium was added exactly to stabilize the structure in this configuration. And that's where the actual name of the zirconia comes from. Yttrium stabilized tetragonal zirconia polycrystal. That's the name of the zirconia that we usually use. And usually it's also referred to as 3YTZP, which comes with 3 mole% of yttrium. In this zirconia polycrystal, usually has about 0.25% of aluminum oxide, which is actually what gives the strength of the material and also the opacity. And usually these materials, they come in the end, you will see about 15 or less% of the cubic phase embedded in the material during the production. So that's zirconia, and that's the material that does not contain silica. How do I bond it to that material then? Well, we know that bonding to zirconia is not an easy task. And again, the absence of silica renders the material not etchable with hydrofluoric acid, and also we cannot silanize because there is no silane on the surface to be silanized. Well, we usually clean the surface. It's important to have this sandblasting, but as you probably remember, sandblasting zirconia was always a controversial aspect because some people have shown that sandblasting zirconia with a too strong pressure or too big particles can actually trigger the transformation of the tetragonal back to monoclinic and generate weaknesses within the material. So sandblasting seems to be important, but with aluminum oxide, particles is smaller than 50 microns and usually at a lower pressure. We don't need a high pressure to clean zirconia surface because they usually come already from the milling process, already clean, and we usually do that for 10 to 15 seconds. But what is probably very and most important, if you will, when bonding to zirconia, instead of using silane, we do have commercially available nowadays what is called the functional monomers, or also called zirconia primers. These materials are MDP-based materials that offer chemical adhesion to zirconia, albeit it's a very weak chemical adhesion, much weaker than the covalent bond we obtain with the glass ceramics, but still it's a let's say recognized bond that we should always be able to accomplish in order to secure my cementation of zirconia crowns. What are the possible reasons that zirconia may failure? And when we look at the clinical data or literature, clinical studies, we will easily see that one of the most technical problems with zirconia in clinical evaluations is exactly the debonding of zirconia. You will rarely see zirconia breaking. You will see veneers chipping, veneers breaking, but the zirconia itself, unless there's a big mistake in the designing, but zirconia is rarely will break. But the failures that we see clinically are usually associated with debonding. So what are the reasons? Well, probably the zirconia was not sandblasted. So sandblasting is let's say an important step. The primer was not applied, or you did not apply an appropriate primer. Again, does not help to apply silane on zirconia. Saliva contamination is a big issue, as we know. Clinically, what we do, we receive the crown, we want to first do the try-in. We want to try the crown, whether it is fitting, or the bridge. And yes, there will be saliva contamination for sure. And we learned over the years that saliva is a very bad contaminant for zirconia, because the organic elements, the proteins in saliva, they react with the oxidized surface of zirconia. So it's not only a contact and then you rinse it, is clean. There is a chemical reaction there, an oxidation of the surface that does compromise the bonding of the primers. So saliva is a big issue for zirconia, and clinically it happens most of the time. Another reason is if you apply your adhesive after applying the primer, but you do not cure it, you need to stabilize that adhesive as well. And ultimately, you are utilizing a cement that is not a dual cure, and you do not accomplish a proper curing of the cement underneath your crown. When we go to the literature for all these review, systematic review and meta-analysis, we found exactly these. The combination of this mechanical, which is the sandblasting, plus the chemical, which is the zirconia primer, seems to be the most reliable way to bond to zirconia. So in summary, this is what we do. We sandblast with this aluminum oxide particles, 25 microns or smaller than 50, a lower pressure, 10 to 15 seconds to cover the entire intaglio surface. And then, of course, I will decontaminate the surface. So I did my try-in, I did my adjustments when necessary, and this is the final stage. Decontaminate, and then I apply functional monomers, which are not silanes, but functional monomers or zirconia primers. It's an analogy of the silanes we apply. And there are some papers, including Dr. Matthias Kern and others, that they always recommend the cementation of zirconia also with an MDP containing cement. As far as I know, the only cement that contains MDP in the general world market is Panavia from Kurare, a Japanese product. I don't know if it is available in Iran, I believe so. And some other small products small companies that might place MDP. Again, the reason why MDP is a key component here is because the functional monomer that is able to bond to zirconia is based on MDP. So MDP itself is the chemical component that bonds to this oxidized zirconia surface, producing some chemical adhesion. But again, do not trust this chemical adhesion as your main retention mechanism. Your crown needs to be fully well prepared. We have to follow all the prosthodontics requirements for the stabilization of the crown, retention, etc. And we just try to get additional bond to favor the retention and also the sealing. However, we know that once the primer itself is really important because it does promote bonding to the ceramic, having MDP in your cement is not necessarily the most crucial. So the cement choice is less essential, but of course, resin cements will always be preferred. And if you have one containing MDP, there are some evidences that support additional longevity when you do that. Well, as I said, contamination by saliva is a big issue when we are bonding to zirconia. And the manufacturers, the industry already discovered that, and there are some studies that were done in order to what we can do if the surface is contaminated. Well, from some of these initial studies, people discovered that alkaline solutions or solutions contain strong bases or strong alkaline components apparently were able to remove the damaging effects of saliva on the surface. And so as we can see here, several airborne particles, sodium sulfate, which is actually a detergent, hydrogen peroxide, sodium hypochlorite, and so forth. Many were tested. And the industry themselves, they were smart. They already prepared and created products that are based on these alkaline solutions in order to decontaminate the surface. And I tell you, regardless if you use Ivoclean, Zirconium, or some of these other products that are available in the market, might have some in Iran that I'm not aware of, they are effective. They are alkaline solutions, as we can see here, when we apply alkaline solutions or when the surface was not contaminated, we were able to get, or they were able to get similar results. Detergents are not so effective, just water is not so effective. Hydrogen peroxide is not effective at all, so do not use. Actually, I ended up compromising because of excess oxygen in here. So my recommendation is that you go for some of these commercial products that might be available there. So after you try in, there is contamination, you can apply these on the surface for 20 seconds and rinse with water. It's a pretty straightforward, very simple procedure that we apply, and we clean the surface for cementation. Okay, very well, folks. Now we're just gonna review then the recommending bonding protocol. If we are dealing with the porcelain veneer, so I do the porcelain first, sandblast if there is a need for that. Eventually comes already blasted from the laboratory. And then what you're gonna do in your practice? Well, if it is already only sandblasted, you can just do the try-in, you can rinse, and then you go for hydrofluoric acid etching, 60 seconds, you rinse, you dry very well, you check if there is any excess etching or over etching, any whitish surface. If there is any whitish surface, then you either ultrasonicate it for 5 minutes or just apply phosphoric acid for 10 seconds to remove the debris, phosphoric acid for 5 seconds, then you rinse and you dry again, and then you can proceed with your salinization. Remember, always a thin coat, a single coat or double maximum. Warm air if you have it available. In 30 seconds, you are done, or just leave the tooth on the side while you go and treat the tooth. I mean, leave the veneer on the side and go to treat the tooth as a regular procedure for bonding that you will do. If there is enamel, you etch the enamel with 30 seconds, phosphoric acid, you rinse and dry, you apply your adhesive. Usually there is a recommendation with a rubbing action to, again, favor the solvent evaporation, which is really important. Solvents are present in most of our products, and they're there for a reason, just to make the product usable in terms of, in terms of viscosity, application. But the solvents, they do not help in anything at all. They need to be evaporated before you cure. And if you are dealing with a veneer, you can apply the adhesive, and then you can cure the adhesive and the cement all together through the veneer. But if you're dealing with a crown, I always recommend that you cure your adhesive first to ensure the bonding, and then you proceed with your cementation. But if we are dealing now with a zirconia then, so the zirconia, again, there is a need for a sandblast. It's probably more important for zirconia than it is for veneers or feldspathic. Then I can go do the try-in rinse. There will always be contamination, as we know. That's when I apply my alkaline solutions. If there is contamination with saliva, which is, again, very likely in practice. Then only after I decontaminate the surface, I apply my MDP containing primers or the functional primers, which are specific for zirconia. And then I apply the adhesive, which in the case of zirconia is optional because as we understand, feldspathic and lithium disilicate, I do create porosities. And I need a fluid resin in order to penetrate the porosities and ensure the micromechanical retention. For zirconia, I do not have these porosities on the surface. I do not use acids to increase porosity. So I don't need necessarily the application of the adhesive. I can do the cementation directly with the cement. And as you know, for zirconia, you can even use a glass ionomer cement, for instance, if you want to, but resin cements are always recommended. Then I treat the tooth, same way. Usually, if I have enamel is still available, I etch enamel with phosphoric acid 30 seconds. And most of the case, I have denting, and then you're going to have to decide whether you prefer to use total etch on the tooth or self-etch adhesive. It is really up to your preference in that sense. But when you apply the adhesive on enamel and dentin, usually a rubbing action is recommended to, again, favor the evaporation of the solvent, which is always there, and it's important to be evaporated. Then you like cured adhesives. This is important when we're dealing with crowns, even if you're dealing with a dual cure adhesive. I always recommend light curing to ensure, because that's the bond that you are ensuring. And some people are concerned, well, if I light cure my adhesive, my crown will not fit. Well, if that is the case, probably you applied too much adhesive. Right? Because the adhesive layer is also supposed to be a thin layer, usually in the range of 30 to 50 microns. And that is not necessarily something that will compromise your fit, because when you are treating the ceramic surface inside, you are also removing material and allowing space for the adhesive to fit in there. And then you're gonna use hopefully a resin cement. And it's also important that you cure the resin cement from all the different aspects, right? All the margins, all the angles, because we know light does not make curves, although it might do in the space, as we know. But in our case, it does not. So it is really important that you expose all the possible surfaces to the light to ensure polymerization. And before we end, as we saw here, zirconia, lithium disilicate, feldspathic, and then we have adhesives, we have resin cements. These are all, as we call, odd parts, but they can be put together and they can last for quite a long time. But that requires knowledge, of course, of the materials involved, as we saw over here. We need adequate tools. We need the proper primers. We need proper instruments to do the job properly. But in the end, they all look good. And my message to all of you, together with my thank you very much for your time today, and remain calm, kind, and safe through this pandemic situation. And hopefully we all can be traveling again and seeing friends and family in a more comfortable way. I have my email here as well, so please feel free to reach out to me if you do not see it here. Dr. Sara Valizadeh can be a link, a contact for all of us. Thank you so much.
Thank you, Professor. It was great. It was wonderful lecture I've ever listened to. It was great. A very important point I learned from you. I know how much
Thank you much.
thankful to you. It was very amazing. I would like to
Thank
ask
you.
if thank you, Professor. I have the same wishes for you that the pandemic resolve very soon and everybody can travel around the world and see the friends and family as soon as possible. Thank you.
Yes, yes,
I hope
yes.
so. I hope so. Very soon these things happen. And as I ask the audience, if anybody has questions to ask Professor Carmelo, and I by myself, I have many questions. If you let me to ask it from you,
Not a problem.
so I have some question from you. If you let me ask my question. One of my questions is that as you recommended for feldspathic ceramic or glass ceramic lithium disilicate, we apply the hydrofluoric acid first for different period of time, 60 seconds for feldspathic, 20 seconds for lithium disilicate, and after that, as you mentioned, we try to get rid of the salt residue by ultrasonic. But if ultrasonic is unavailable, we can use the phosphoric acid. By myself, many times I have not access to ultrasonic device, so I try to use the phosphoric acid to remove the residue, but the frosty appearance does not appear. And how can I get rid of that? In spite of that, I use the phosphoric acid agent 37% on it for 10 seconds to 20 seconds. But again, the frosty appearance remained. What can I do then?
Well, I mean, that depends on the ceramic. Some ceramics, after you etch, they will have some changes in the refractive indexes. So they still remain, like say, opaque. But once you apply the phosphoric acid, residues are going to be removed. So if you ensure that you apply the acid, even if the surface is still, let's say, frosty or appear, that might be a result of the type of ceramic. But I am, I am quite sure that if you did apply the whitish appearance, that if you scratch the surface, when we see excess residues, we can actually remove them. Other than that, I would say that it's probably a result of the refractive index in the ceramic, but no longer the residue, because the phosphoric acid should be able to easily clean, the actual salts from the surface.
Okay, and I have many questions. Do you let me just ask my second question?
Sure, of course.
Thank you, Professor. You mentioned that if we apply several layers of silane agent, as you mentioned, is not good at all, because 2 or 3 layers of silane layer does not connect together. You want to get rid of silane. One of your advice is using etching to clean it or remove the excessive amount of silane. But what type of etching? Do you mean acid phosphoric or HF again, hydrofluoric acid? What is the etching material?
No, well, yeah, that's a good question, and I apologize if I said something that was not understood. Excess silane, the best way to avoid excess silane is to apply little, right?
Yeah.
If you, for any reason, and I've seen people telling me, oh, you know what I do with my veneers to silanize? I use one of those Deppen dish. I fill it with silane, and then I dip my veneers in there, and they float in the silane. So of course that is an issue. Yeah. But yeah, there is, if for any reason you realize that you apply too much silane, you don't remove silane with acid. The only way to really remove excess silane is to immerse your veneers in boiling water for 10 minutes.
Okay,
Yeah.
boiling water. So no acid,
Or
boiling water in 10 minutes.
10 minutes.
10
Yeah.
minutes.
In that way, you're going to be able to remove all the excess silane layer, and
Okay.
only the bonded layer will remain. So after boiling for 10 minutes in water, you
Okay.
still have the salinization okay. You're actually improving the salinization because you are getting rid of any excess layers.
Okay, I got it. So
Uh,
immerse the veneers or the ceramic restorations, the boiling water for 10 minutes, and after that remove
yeah,
it. Okay, and then
yeah.
continue.
But of course, this is clinically is very not practical,
No,
right?
no,
If
no.
you, yeah. So what people do once they eventually realize, wow, I'm sorry, I applied too much silane.
Mhm.
The easiest way is to use a burr, just grab your burr and slightly remove the layer of silane. So mechanically, you can remove everything. And if you ever have to do that, then you have to start over. You etch with hydrofluoric acid again, you silanate again,
Okay,
right?
yeah.
So yeah,
And
that's why silane is very important. And always be careful when you use your micro brush. It's easy, the surface is really dry,
yeah,
and you apply silane and you see wetting the whole surface.
yeah,
That's it. You don't
that's it.
need more
That's
than
it.
that.
Okay,
Mhm.
great, great. Thank you. And another question of mine was that, oh, you for cementing, for luting of the veneer restoration, I don't know whether I got it properly or not. You mentioned that can we use the flowable resin, composite resin instead of the
Yeah,
light cure resin? So can we, considering the
yeah.
flowability? So because the flowability of the light cure resin cement is completely different from flowable composite resin. Do you advise to use
Uh,
it if
yeah,
we do not
yeah.
have an?
No, if you think that like your only resin cements for veneers are essentially a flowable resin, right? They
Mhm.
are pretty much the same thing. It's a resin with more matrix and less filler particles. It is not an issue. You're going to be able to light cure it through the veneer, so there is no concerns about under curing. And
Mhm.
some people prefer because they say, well, I have some flowable resins with better color that matches better, my veneer or my cementation requirements. So there is no issue. Of course, you have to deal with the viscosity. Some flowables are not as fluid as others,
Yes.
but the most light or flowable resins are okay. I don't see any reason why you cannot use it.
Okay, I got it. Thank you. Thank you. And
Yeah.
another question, if we use the trying paste in the veneers, and I want to get ready about that, after do we should use it before a hydrofluoric acid etching of the veneer, or if we have applied the hydrofluoric acid first and silanize in different approach, we apply
Okay.
hydrofluoric acid, silanize it, and then we use trying paste. Another approach is that we have not applied any agent on the veneer up to now, and then I
Mhm.
use the trying paste. In these two methods, how can get rid of a trying paste? Would you please advise us?
Okay.
Thank you.
Yes. So ideally, try and paste either you apply and use before you etch,
Mm-hmm.
right?
Mm-hmm.
Or you apply and use after you silanize. And the
Mm-hmm.
reason is before you etch, the surface is natural. There are
Mm-hmm.
porosities there. The trying paste will eventually get into the porosities, but the
Mm-hmm.
surface is rather hydrophilic at this point because you didn't etch yet. So
Yes.
by rinsing the trying paste with water, because most of the trying pastes are water-based,
Yeah.
right? So you have to rinse it well, some people recommend ultrasonication if you have it available for 2 minutes. So that facilitates also the removal of the triene paste. But if you apply after the silanization, it's also easy to remove by just rinsing with water, because remember, silanization leaves the surface hydrophobic.
Okay.
Triene paste is usually water-based.
Okay.
So although you're gonna see, yeah, so once you rinse, it's much easier to remove. But ultrasonication, yeah, ultrasonication is a good way to remove any of these debris or particles from the porosity.
Right. Thank you.
Yeah, what you should never, what you should never do, sorry, is to use the triene paste between etching and silanizing. That's when you get in trouble. Yeah.
That's the important point. I should not use triene paste between these two, hydrofluoric acid and silanization. Thank you.
Yeah.
And another question. You mentioned that if we do any adjustment into veneer or any ceramic restorations after the hydrofluoric acid and silanization, we applied it, we adjusted. It's required that the hydrofluoric acid agents and the silanization agent applied again. Is it cause overetching appeared cause or over silanization cause? Because some point adjustment, not all surface.
Exactly. Yeah, there will be no problem to apply again over the surface that is already silanized. If you already silanized, let's say we're dealing with a crown, it is completely silanized, but then you decided to make an adjustment on, let's say, the buccal surface, right? And then you use a burr, you make an adjustment. By using the burr, you ended up removing the silanization, you removed everything that you did on that area. Well, you can redo it again only in that area if you have control of that, right?
Yeah,
but
only on that portion, not all over the surface.
No, you don't have to, but it will be hard. You will see that the acid will eventually go on the surface, the silane will eventually, and there is no problem. Once the surface is silanized, as I mentioned, it's a very strong, stable chemical reaction that you can only remove if you touch with the burr. So the acid itself will not damage the silanized surface, and also the silane layer will not damage the area as well.
It will not be cause over etching or over silanization if we do it again.
Yeah. Okay. No, not a problem.
Thank you. And for adhesive agent that we should apply over the silane before resin cementing, is the, of course, you mentioned that the type of adhesive is not important. It should be unfilled, hydrophobic, HEMA-free adhesive agents, very thin coat. Is it right?
Yeah, ideally should be a very fluid, HEMA-free, pretty much, some companies like Bisco, for instance, Bisco sells one adhesive that is specific for bonding veneers. You don't have to have that one, but ideally you should use an adhesive that is rather more hydrophobic than hydrophilic to avoid potential color changes over time.
That's right. And about the zirconia that you kindly mentioned to it, of course, it was one of the questions of our audience. Have you ever used high translucent or translucent zirconia in your clinical practice, or you have any advice to us to follow it to our practice? Would you please?
Yes, excellent. So you're probably talking about of these new monolithic zirconia, right? Material that are, well, in general, all of these monolithic zirconia, they are actually more translucent, right? The reason they are more translucent is because they have been reduced the concentration of aluminum oxide. Remember, it was 0.25%, And with these new materials, it's usually about 0.1% or 0.15%. So that reduces opacity right there. Also, they have modified the mole percent of yttria in these zirconiums. Instead of 3%, they raise it up to 4 or 5% mole. The end result is that, remember that for YTZP, you have less than 50%, 15% of cubic phase.
Yeah.
With these new materials, you have way more cubic phase, and that's why zirconia is more translucent.
Yeah.
Okay. In summary, all of these new zirconia, monolithic zirconia materials, they are, in terms of properties, weaker than the traditional zirconia. So, and they are, let's say, significantly weaker to the point that their resistance and reliability is more similar to lithium disilicate.
Okay.
So lithium disilicate and monolithic zirconia for posterior teeth, both of them will have similar mechanical strength, right? Bonding to these monolithic zirconia, we don't have a lot of literature out there so far.
Yeah.
What I could retrieve is people are doing the very same procedure they do for the traditional zirconia. They do a sandblasting inside, they apply a zirconia primer with this functional MDP monomers, and follow the protocol as they would for a traditional zirconia. I have read one article that apparently indicates that the zirconia primers are not as effective for monolithic zirconias than it is for the traditional zirconia. But again, these are all laboratory studies. There is very, very little conclusive information on that. My goal or my point here is I honestly don't see any reason to use a monolithic zirconia in a posterior tooth because I have lithium disilicate, which is, in terms of mechanical properties and reliability, very similar to this new zirconia, translucent zirconia. And then if the mechanical properties are similar, both of them will be okay for posterior tooth. Why would I choose a lithium disilicate instead of a monolithic zirconia? Well, simply because with lithium disilicate, I can bond. I can really achieve a much better bond with lithium disilicate that I can get with zirconia. So to me, yeah,
One
to
advantage,
me, I see no reason.
One advantage that I have read in several articles is about thickness of the material that is required. As you mentioned, the mechanical properties are similar, but the thickness of the required material is different. For the lithium disilicate, at least I need probably 1.5 2 millimeter thickness to have integrity and mechanical properties enough to stand against the masticatory forces. But for translucent zirconia, about 0.3, 0.5 reduction is required, probably according to the papers that I have read. And this advantages for the patients with the worn teeth that have not enough space in the posterior area for reductions, and the short teeth that have not enough tooth structure to be removed for about 1.5, enough even after crown lengthening. So do you recommend using the translucent zirconia for the posterior area of these patients? Do you recommend it? Please advise us.
I understand your point. I understand your point, and indeed, there is a belief that zirconia will be stronger than lithium disilicate in thinner thicknesses. Well, I would be cautious about that, because when you look at the mechanical properties, fracture toughness, and all the other properties of all monolithic zirconias, they are very similar to lithium disilicate.
Yeah.
And when they test this, they test then with the similar thicknesses, of course, right?
Yeah. Yeah.
So I believe that zirconia will perhaps have stronger properties, or maybe you can prepare thinner zirconia crowns than you can with lithium disilicate, but it remains to be seen. I would be very concerned with what I see some people recommending for monolithic zirconia, which is a very thin preparation, like gold, like we used to do for gold, right? Very thin. And my concern is particularly at the margins. You know, people are recommending sometimes this feather edge,
Yes,
right?
yes.
Or very thin. Yeah,
Yes.
and unfortunately, zirconia does not stay well in a very thin margin.
So what do you advise for these patients in the posterior area that has not enough tissue structure and enough adequate space?
You know, if they are, of course, the better you have is gold. The better you have for these cases is gold. If the patient does not accept gold, I would eventually try with zirconia. I agree with you that zirconia might be an option, because we already know that lithium disilicate will not work in a very thin prep.
Yeah.
I am, if I have to anticipate, I would say that with the monolithic zirconia, you will still need at least 1 millimeter thickness.
Okay,
Yeah, that's my guess. I haven't tested, I haven't worked in that, but from the mechanical properties that I see, I will be concerned with way too thin zirconia.
So by this way, your comments is gold crown or adhesive metal only at the first, and second would be zirconia if we have to, but with 1 millimeter thickness. Oh, 1 point.
Yeah.
Great. Thank you.
Yeah.
And sorry, I have many questions, but I don't want to take your time anymore. There are two questions from our audience. One of the question is that what temperature for ultrasonication do you recommend? It is one of the question of our audience.
Okay, well, room temperature. Yeah, room temperature. Yeah, ethanol in room temperature, there is no need for raising the temperature. It's just the vibration itself.
Okay, as another question, first they are thankful to you for nice presentations. They ask about, please give us more information, zirconia primer regarding chemical combination. I don't know what is it's not clear question. The chemical composition of the zirconia primer?
Okay, the chemical composition of zirconia primer, of course, manufacturers will never tell you in details, but they are all based on these MDP functional monomer, which is methacryloxy, propyl teramitroxy. You know, there is a big name, but MDP is the same functional monomer that curare, developed by curare in Japan, right? And they used MDP to improve bond strength of self-etching adhesives.
Okay. Do you let me have two more questions? just two, not more. Do you let me?
Oh yes, I really have another class to give at 9:30 here, but that's fine. I can try to answer quickly, or you can send me by email.
Okay,
please.
So I don't take your time.
Yeah.
But one question.
Not a problem. It's my pleasure. It's just that I have another
one question.
exam.
One question. You mentioned that for cleaning of the zirconia surface after contamination with saliva, you recommend some materials as Zirclean or EvoClean because of their alkalinity. Last week we had a lit review for this issue in our department. And there was several articles that also advised for using sandblasting with in low pressure with a particle as well, instead of the Evoclean or Zirconium with alkalinity. What is your
That's
comment?
fine. That is fine as well. Usually, sandblasting will also remove these oxidized surface. The primers or the Zirconium or Evoclean, I think they have just the advantage of practical, right? You are in practice. Not everybody has a sandblast machining practice. So, but yes, you can always sandblast if you have it available and remove the effects of contamination.
Thank you, Professor. It was great. Thank you for taking time out of a business schedule. As I told you before, it was amazing. I hope that you give us another opportunity for your webinar with another title, any title you like, but it is the
It'll be
honor
my
of Tehran
pleasure.
University. Thank you. It is an honor of the Tehran University of Medical Science that have you in this webinar. And thank you for your time.
My
I don't know
pleasure. My pleasure.
how can I appreciate it? Thank you.
I
Yes,
really appreciate that. It was fantastic. I'm glad to see, you know, over 40, almost 50 people. I had more than 50 people at one time. Again, thank you very much for your kind invitation, Sarah. Thanks for arranging this. And hopefully, yeah, we were going to expand this and maybe, you know, create some sort of collaboration that we can teach from different areas. It'll be my pleasure.
Sure, I will
Okay.
ask Sarah to organize this webinar or program again, if you kindly let us, if you kindly permit us to have these collaborations. Sarah, please,
I
if you have
will.
any points to add for this
webinar? Thank you, Rick, for such a wonderful presentation and sharing your experience and expertise. And you're not just like just professor, teacher. You're like mentor, and I learned a lot from you beside dentistry. Thank you for all your support.
I really appreciate it. Thank you very much.
Thank you.
You enjoy the weekend ahead. Enjoy the weekend ahead and your evening, right?
Thank you. I hope so. I have a good weekend for you. I wish a good weekend for you as well. Thank you, everybody, and have a nice night and the Friday in Iran and all over around the world. Bye bye, everybody.
Very well.
Have a
Thank
nice
you so
day.
much.
Bye bye.
Bye bye. Bye bye, everyone.
Thank you.